So as far as like when you talk about the limits key concepts, the first thing is that the presentation, like how do we tackle the presentation? So when you talk about limits, now, for example, if there is a function, now when you want to show that limit x tends to 3 uh, for this function, what does this actually mean to us? Or like, for example, limit x tending to 2, as x tends to 2, what is the value of this function? Now, logically speaking, when you are estimating limit, you're approximating the y value as x approaches to 2. Now, when you talk about here, let's say, I know that when I take, let's say the function, let's say y equals to x squared. Now, as I approach from the right side, let's say from here, or I approach from the left side, when I'm not at exact point 2, but I'm somewhere like, let's say 1.999999, something like that, what's your y value? So as x tends to something like this, what's your estimate, or what's your y value? That we call it as limit. Similarly, if you approach from, let's say, right hand side, like for example, you take x value as not exactly 2, but 2.0000000, let's say 1, like a very like small value compared to, I mean, close to 2. So now when you're looking at these y values, now they help us estimation of, like the exact value at a particular point. So as far as the limit concept, now limit is basically the estimation is meaningful, or estimation can be done when a function, like let's say estimation around a point can be done when, like for example, function has both the limits. When you talk about the limit x tending to a positive, now what does a positive mean to us? Now a positive is something where, like, your function is basically you're approaching from the right side. Okay, so your a value is like your x value somewhere little higher than, like little means I say infinitesimally small compared to the point which is you're exactly finding the y value at. So let's say 2.0000000 and so on. What's your y value? That's called right hand limit. Now when you talk about the left hand limit is nothing but it is shown as limit x tending to a negative. A negative doesn't mean negative value. A negative simply means the y value when x is slight a bit lower than a. What's your y value when x is slight a bit higher than a? That's your right hand limit. When x is slight a bit lower than a, that's called as left hand limit. So that's as far as the basic terminology is concerned. Now let me just show a simple example here. Now let's say our function is, we have a function, for example, I'm just showing it to you here. Now for example, let's say this y equals to um, x squared plus 4 function, or x squared plus 1. It's not exact graph it's look like. So let's say this x squared plus 1 function. Now when you're finding out the right hand limit here about a point, let's say I'm taking here as 1, and I want to find out what's my y value according to this. So limit, if I'm asked to calculate limit x tending to 1 positive. Now what does it mean is that find out the y value of the function when x is slightest, like slightest higher than, like 1. So obviously you can see that is approximately equals to nothing but, so when you look at for this function, that will be nothing but 2, because whether it is slight a bit lower than 1 or slight a bit higher than 1, eventually you're going to take around 1, which is 1 square plus 1, which is 2. Now similarly, if you take limit f for f of x tending to 1 negative for the function, now that's nothing but, let's say, once again 2. Now here it's this is showing that both the values that is you're estimating, if they are, like coming falling very close, it means you can estimate some of the bigger pictures of this is like maybe function is continuous, or function has the limit, like for value to be estimated around a point, these two must be the same. Now let's take an example where limit doesn't exist. So here, if your left hand limit and right hand limit both are the same, then the limit exists. If the limit, left hand limit is different and right hand limit is different, we say that limit doesn't exist. What does it mean? Either there is a break in the function, or function is discontinuous around that point. So let me give you an example about here now. So for example, let's say this is a function which is about at x equals to 1 here, and here it is, let's say I take this as 2, and this is, let's say, 1, and this I would take it as 2. Now what I'm asked to do is, like, for this given function, estimate the left hand limit and the right hand limit. So when you estimate the left hand limit, for example, if I got a function f of x, this function, and I'm estimating the right hand limit, let's say 2 positive, obviously you can see that if I take the function here, the value, so this limit value for this function is nothing but 1, because when you look at, as I go slide a bit, even slowest, or even the lowest value compared to what I have got, like, increase, if I do to 2, let's say 2.000000 something, like up to like infinity decimals and then some number, then you'll get the answer as right hand limit answer will be nothing but 1. While you talk about the left hand limit, when x is slight bit smaller than 2, let's say if your function is x tending to 2 minus, the value of this is nothing but 2. So this is something which is called as the left hand limit. Now here your right hand limit and left hand limit both are different, and hence you say that limit around the value 2 for the function won't exist. This will say it won't exist. So in this part, what we have is basically there are two functions. Let's say one is y equals to x squared for x higher than 3, and second function is y equals to 3x when x is less than or equals to 3. Now logically, when you see, I want to see that whether limit at 3 exists or not. Now when you say limit at 3, it means that your two of the important thing is that your left hand limit, so limit x tending to a positive for the function, and limit x tending to a negative for the function, it must be the same. These both must be the same value. Now, when you look at a simple evaluation of the limit here, now x more than 3 when you say, now if I want to evaluate what's the right hand limit, which is 3 positive. Now, obviously, I'm going to choose this function, right? Because this is valid for slightly a bit higher than 3. So that's nothing but 9, which is here. Now, when I look at the left hand limit, which is now slightly lower than 3, obviously, I'm going to use this function, which is nothing but 9 again. So as you can see, even it is evident from the graph. When I graph them, you can see that both of them are having approximate value 9 around the same point. So we will call here that since the right hand limit and left hand limit both are the same, hence the limit exists. So this is a simple, meaningful expression. So for this function, you have got, let's say, two hybrid functions, let's say, which is, I mean, this is a single hybrid function, which is defined for 2 to 5. It is 2x plus 5. Between 0 and 2, you have got this line negative x plus 3. And for y equals to 3, for x less than 0. So when you talk about y equals to 3, it is going to be somewhere here. That's your y equals to 3 line. Okay, so now when you want to check whether the limit about 2 exists or limit about 0 exists. Now this graph won't be given to you every time. So what you do is, let's say this graph is not given to us. So what we'll do is I'll just keep this framework this picture out of the frame. So what we have is, let's say I want to evaluate even without looking at the graph. So now the question here is that how do we firstly evaluate the left hand limit and right hand limit for the given question. So let's say what we have is, first thing what you can see is that if I want to evaluate about limit, right hand limit about 2 positive, as x tends to 2 positive, what happened is that you can see that which function I'm going to take is that this one. You can see it is valid from more than 2 and less than or equals to 5. So when I evaluate the right hand limit here, it is nothing but 2 times plus 5, which is nothing but 4 plus 5, which is 9. So the right hand limit according to this function is 9. And let's see at 2, what's the left hand limit? So limit x tending to 2 negative, which is like lower than, is y value slightly lower than 2. So for that, you can see I'm using the second function, which is between 0 to 2. This is the function that is valid. So that is nothing but negative 2 plus 3. That's going to be positive 1. So since you now here you see that left hand limit and right hand limit, they both are different, then you will say that the limit doesn't exist. And now if you look at the graph that I have sketched, that was between, this is how it looked like. So this was something which was 9, and then between 0 and 2 it is here something like this. So that was at 2, this was, there was no point here, and then at less than 0 it is at y equals to 3. So now I can clearly see that there is a jump in the function and jump in the value, so the limit does not exist here. You can't estimate the y value around that point. In simple term, that's what you can say. Now when it comes to, let's say I want to find out what's the limit around 0. Let's say when, suppose let's say limit f of x tending to 0, does it exist? Now this is one of the university level calculus, like where if you don't have understanding about the left hand limit and right hand limit, it might trouble you a little bit. So now when you look at the limit for x tending to 0, I would just find out limit when x is slightly a bit lower than 0. So like 0 point, negative 0.000000 and so on, like 0.1. So when you look at this, for x less than 0, you can see my function that is valid is y equals to 3. So that's nothing but y equals to 3. It's independent of x. While if you look at its right hand limit, which this is valid for x more than or equals to 0, so I'm going to use this function, limit x tending to 0 positive, that's going to be f of x, which is nothing but 0 plus 3. So that's nothing but 3 here. So you can see since both the y values or the limits are the same, we say that the limit around 0 will exist. In this question, what we have is there's a hybrid function, which is x minus 1 the whole cube, and y equals to 1, which is valid for different x values. Now, when you're asked to calculate limit x tending to 0 negative, which means the slide when x is slightly lower than 0. So obviously, you can see that I'm going to use this function when x is slightly lower than 0. So I'm going to use this function, which is nothing but 0 minus 1 the whole cube, which is negative 1. And now when I take a slightly bit higher than 0, obviously my y value is nothing but 1. So since your left hand limit is um, uh, nothing but negative 1 and right hand limit is positive 1, hence you say that limit does not exist at x equals to 0. So you can't estimate the y value at x equals to 0 because you can see there's a jump here. So when you have three functions here, let's say, which is in form of hybrid function, single hybrid function. Now, when you talk about, let's say, our first one is x more than 3, the valid function is x squared. At x equals to 3, there's y equals to 5. So that's like a point, and x is less than 3. This is y equals to 3x function. So first part is to sketch the graph. So obviously, when you sketch the graph, this approximately graph look like. So at 3, there's like x more than 3, this function is valid. At 3, it's y equals to 5. So at 3, it's like a dot. And for x less than 3, I have got this line. Now, when you want to evaluate the limit, when you're finding the limit as x tends to 3 positive or 3 negative. So now here, for 3 positive, I'm going to use this function, but the first one. So that's nothing but 9. When I say x tending to 3 negative, which is from the left side, I'm going to use this function because this is valid for x less than or equals to 3, less than 3. So that's nothing but 3 times 3, which is 9. So you can see that left hand and right hand limit is the same. So obviously the limit is going to exist. Now, irrespective of the exact value at that point, I'm able to estimate that as I approach from both the sides, you can see that approximate the y value that the function gets is approximately 9. So that's how you justify that limit exists around a point. Even though that the y values is not the same, at that point the y value is not the same. You can see that at x equals to 3, the y is 5. But if you approach from left and right, it is approximately 9. That's how you're going to estimate. So now when you're evaluating the limit for trig functions, what is really important is the two important relations. Now, when you talk about in the radians, like for example, sine x function, what's the y value when sine x function is like when as x approaches to 0, as x approaches to 0, what happens to sine x value? And based on that, we're going to understand what's the limit for sine x over x as x tends to 0. So what I would like to show you is a interesting calculation on calculator. So what we have is, let's say I'm trying to show is that what's the y value or the limit around when x tends to 0, when x is close to 0. So now let's say I'm just going to take one thing is that I'm making my calculator radian mode, and now I'm taking, let's say, finding the value of sine 0.001. And you'll notice that. So first let's do at sine 0.1. So what you notice is that this value will also be close to 0.1. The sine ratio value will also be close to 0.1. So you can see that it will be close to 0.1 because it's like 0.0999. If you round up to one decimal place, it comes to 0.1. Similarly, now if I just go on like that, so let's say I want to find out the value sine 0.01. So let's see what happens. Now it's pretty close to 0.01 again, because if you convert to um, the decimal form to one decimal place, it'll be 0.01 itself. This expression is nothing but 0.099 currently, and if you round off, it'll be 0.01. Now, if I take another thing, which is like sine 0.0001, there are four zeros and then one. And what you'll notice is that the final answer that you get is also having, now it is exact value. This is 10 to the power negative 5. This is 10 to the power negative 5. So now if I go on further, you'll notice that whatever the y value you're taking, like for as x tends to 0, what is really interesting is that sine x actually becomes same as x. Sine x approaches to the x values. And the reason is, you know what? It's like this. So sine x graph is something which is here. There's a sine x graph. And when you look at y equals to x line, if I zoom in, what happens is that if I look at as an approximate, y equals to x line is something like this. So as you can see that the y, as x approaches to 0, you can see that the y value, which is for this sine x, is also approaching approximately this line. So it's like if you zoom in, your sine x curve and this curve, almost they overlap each other. And as a result of that, what we have is sine x upon x. So because this is approximating to x, so what we do is x 10 x upon x, which is 1. So when you do this particular thing, you'll notice that as x approaches to 0, the ratio of sine x with the angle for which you found out, which is x itself, will be always 1. Now let's just take a simple example here. So if I have to find out now, let's say I'm just doing one thing is I'm just dividing this answer, divide this answer basically by, divide this answer by 0.1. So let's say I'm assuming that. So you can see that this answer is 0.9984, which is close to 1. Similarly, if I divide this answer divided by 0.01, now you'll notice here it'll be approximately 1. So it's 0.9999. Now, obviously, this answer is the same. So it'll be if I divide by 0.0000 and 1, you can see the answer exactly 1. So as x tends to very close to 0, the sine x over x, that becomes actually 1. And so is with the tan x graph. So when you talk about the tan x graph, so this is the limit formula actually for tan x. As x tends to 0, tan x over x will become also equals to 1, because sine x and tan x, they become close to x value as x approaches to 0. So if you're finding out the value of tan 0.00001, it is same as 0.0001. If I'm finding sine of 0.05, which is close to, so you can say, okay, this answer is going to be close to 0.05 approximately. So this is a basic formula that we use in the limit evaluation. Let's see some examples how we use this formula to evaluate the limits. Now, as far as the limits basic concepts are concerned, what you're going to do is you're going to first evaluate. Let's say I'm just, for example, I'm finding out the limit sine 4x over x as x tending to 0. So I know that sine x over x, so whatever is this angle, if I have the same angle in denominator and if my answer becomes close to 0, this answer is taken as 1. So this is something which is the formula. Now, if I have sine 4 times x over x, now you can see that this here is the 4 times the angle. And in the denominator, what we have is we just have x. So what we can do is we need to make sure that the angle that you're taking here, it's 4 times x. I need to have 4x here as well. So it is going to be 4 here, and then you multiply and divide by 4 to maintain the neutrality. So why it is to make sure that I get this x and x in the same, like, the angle should be also in the denominator. So you have numerator 4x, the angle should be also 4x in the denominator. So what we get is the limit which you find out here. So this part, you take 4 outside. So limit x tending to 0. The sine of 4x over 4x. Now we can see that the angles are the same. It's like sine theta over theta. Now this answer, since this answer is 1, for me this answer is 1. Hence the answer for this limit is going to be 4 times 1, which is nothing but 4. So that's the x value of this limit. So now let's the next example is that I want to find out what's the limit as x tends to 0 for sine 3x times sine 5x times sine 8x over x cubed. Now this is an interesting question. Now what we are doing is we are evaluating the limit for sine 3x, sine 5x, and sine 8x over x cubed. So what we do is basically out here is that we are going to apply the formula, which is sine x tending to 0. X tending to 0, sine x over x, which is equals to 1, or sine theta over theta equals to 1, as theta tends to 0. So whatever is the angle out here, make sure that you have this as well here. Now, what we do is, as you have the evaluation of the limit, for limits, what you can do is, if you're finding out the limits of product of 3 functions, what you can do is find out the limits of individual values, individual functions, and multiply them. So here what I do is I split them up as sine 3x over x times sine 5x over x times sine 8x over x. This is something which is important. So I broke this x cube into 3 factors, like x times x times x. So now the next step is to get these angles same. Now here you can see the angle is 3x and here angle is x. So what I do is multiply this by 3 and divide it by 3. So you have at least the same angle now. Similarly here, I needed 5, so I multiply this 5 in denominator. So to keep the equation neutral, I also multiply numerator. So now here I have 8 here, so you can multiply this by 8 and also 8 in the numerator. So now since all the values that you have here, since they are approximating to 1, this will be 1, this will be 1, so the exact limit will be 3 times 5 times 8. So whatever the answer is, around 120. So the limit or the y value that will approximate, that will be this function approaching as x tends to 0 will be approximately 120. So when you're finding the limits as x approaches infinity, there is a standard procedure for this. Generally, it's for rational functions. Now, when you do this, what you do is you divide the numerator and denominator by leading term, which is x squared here. So what I do is I divide both numerator and denominator by x squared here. And since what we remember is that as x tends to infinity, 1 over x tends to 0, 1 over x squared tends to 0, 1 over x cubed tends to 0. Everything will become 0, which if required. Now what happened is that this upon this is 3x squared upon x squared plus 3x upon x squared plus 7 upon x squared. We can isolate them. That'll be x squared over x squared plus 7x over x squared minus 5 over x squared. And obviously this simplifies. And here you need to mention that this limit extending to infinity. So what we get is, now this will be nothing but limit as x tends to infinity, 3 plus 3 over x plus 7 over x squared plus 1 plus 7 over x minus 5 over x squared. Now since these values will come close to 0 as x tends to infinity, hence my value is, the y value for the limit is 3. Now same way here, the leading term you can see is the x squared. So what you do is divide numerator and denominator by x squared term. And as a result of that, this simplifies to 7 over x plus 5 over x squared. And here will be 1 minus 3 over x plus 2 over x squared. And all these terms become 0, 0, 0. So it'll be like 0 plus 0 over 1, which is 0. So that's the value of the expression as x tends to infinity.